Hello and welcome. It's been about a week, and not without good reason. Last Sunday, right after I got a video up, I believe it was Sunday, might not have been, I went inside, went to sleep. When I got up, my computer was off, lights were off, everything was off, and so I got the power turned back on. Breaker had blown, the surge protector that I was plugged into had popped, and so I got power back on, turned the computer on, and well, it didn't recognize any of my hard drives. Well, okay, so I tested my power supply plugs, got voltage across all the rails, everything's normal, everything else is fine. Okay, let's test the motherboard. So I broke out a CD-ROM and plugged that into my serial ATA and powered it and started up, and well, recognized the CD-ROM just fine, so I put it in each serial ATA port to make sure that they were all working, and well, they were. Well, that only left one thing, the hard drives. So I broke out an enclosure and put my hard drives in that, and none of them worked. Well, checked the warranty on 3 of them, and they were no good. And the 4th one, well, it's being replaced. Should be here in the next couple days. Since we have the holiday coming up, probably not until maybe even the week after. So the 3 that weren't under warranty, I popped the interface PCB off the back of it, which is just, like 4 or 5 screws, and it just is, the connections are made by the pressure of it being screwed down. Flip it over, and well, the motor control driver chip has a big crater in it on all 3 of them. I wasn't going to take apart the one that was under warranty, so I can only assume that the same problem, obviously not in the same chip as it's a solid state, but some sort of chip in it must have also blown. So yeah, my main computer is down right now, and I am on my old server. I know it looks the same, but hey, it's just a background. Keep in mind that this one does not run as well, and I just had to put WXDev and IDA and all my stuff back on it. But yeah, today we are going to actually call some functions from the dummy via our injected DLL, and we probably won't get into passing more than just like a simple integer argument, but or return values, because that's going to take a little while. It's better saved for the next video. I thought this might take 4 or 5 videos. It might even take a 6th one, but I think we can wrap it up in the 5th, and then we can move on to something else. Like baby steps. What does an array look like when it's being accessed? What does a structure look like? How do you figure out how big a structure is, and how big each member or field of the structure is, and how do you reference those things and whatnot, and important shit. So we have the control tutorial. Yeah, I had to load it from the Dropbox because I lost everything. So happy about that. I am going to repair my 3 hard drives. Just got to order a couple parts and reflow them and see if it goes, or I might just order the whole PCB. I'm probably just going to order the whole PCB. It's going to cost like 10 times as much to do that, but it'll be easier. So if we open up my DLL, not that, control DLL, right here, it's going to open right here, and we open up DLL main. We're going to see our callback first, and then our main, which we don't need to look at the main ever again, really. We might once, but here, yeah, we will look at it in the next video for a split second. So here's our window procedure, and this is the message that we want to send it that will call some function within the process. Well, what function do we want to call? Well, let's open our dummy in IDA, and it starts here. We follow this call and we look down it and we see cexit. Let's follow the call above it because everything else is initialization and cleanup. And then we see our code and we see all these variables and blah, 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 one argument, and we see set console title. We see that it's recognized that this is the H instance, and then it's saying this blah blah blah, the name, and then we see our third argument here, which is going to be our window procedure. We know that because register class, if you look it up, you would be able to know what the arguments are. So we want to look at that window procedure again and come on down. We remember our cascaded jumps case statement, or well, our switch statement. And we remember that this one over here added some so this was our L param. It added 2 to it, added 4 to it, added 7 to it, stored those in registers, did some multiplication, did some division, and it really wasn't anything interesting. Like, we don't really need that. I don't see any reason to really use it, so we're not going to. But if we wanted to, we would know that if we called this specific address, this location 4013E8, to run that function, we would actually need to, since this is inlined, we would have to load our LParam NDSI, and then we would actually have to, after this, it would try to clean up. It would try to do all this, and we'd probably run into errors. There is a way to do it, but we'll get into that a little bit later down the road. So today, we're going to look at the string outputter, we'll call it, and probably the variable modifier. We might only have time for one, but if we do it quick, we can probably get to both of them. I did just get off work, and as you can tell, I don't sound half as bad as I did before. I'm feeling much better. That's great, great, yay for me, whatever. So we compare with 1133, and if it is, we go over here. If it's not, well, if it is, we come over here. If it's not, we come over here. So it is 1133. We want to output strings. And we see that this call takes one argument, this here, which is referenced in all of them. And so we know that that's got to be something that we're passing to it. Well, let's take a look. We're not too sure. It's not an argument. The arguments are here, and these are obviously the hwind and then the message, wparam and lparam. So to see, if we see it here, and it's just, you know, it's nothing too special. And really all it is the top of the stack. This is equivalent to saying push blah, push this offset string, and we would know that if we viewed the, it's in options, general, and stack pointer. So we see the top of the stack is 2C. So right here we're putting that variable. So top of the stack right here. And it could get confusing when you're looking here and you're like, wait a minute, but this is because you have to remember that it's backwards. This is going to go on, and this is going to go on, and the top of the stack is always going to be the last one. So we are taking one argument, which is a pointer to a string, and then calling this function. So we just need to pass it a pointer to a string. So let's write a function pointer really quick for that. And to do that, I think I'll just make a spot up here that says function pointers. But you don't have to do it globally, but we're going to. Why not? Now, does it return anything? Do we need a return type? And we see that it just calls printf, and then it cleans up the stack. So it's going to return whatever printf returns. Well, if we want to know what printf returns, we can just pull it up on the net and scroll down and see a return value. It returns the number of characters printed or a negative value if an error occurs. If format is null, the invalid blah 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 blah. So it does have a return value, and it's the number of characters that were output. Is it really important? Does the program use that information anywhere? Well, no, it doesn't, and we don't really care about it. So we can use a void pointer. We could use an int pointer and actually return that value because it's going to be in EAX, but we don't really care. So let's say void, how does this work? It's been a while. I want to say it's something like void pointer output string, and it takes a character pointer. Type name is jar. There we go. Is that right? No, that can't be right. You know, I'm not sure that that's right. No, that's not right. We need parentheses here. And then character pointer. There we go. So now we have a function pointer with no value. Well, what's the address of our function? And we see that it is 401348. But is this address ever going to change? Is it always going to be that address? Well, in an executable file, it does, in the PE header, it does have an area that says, hey, this is my base address, use this. And so the likelihood of this changing is slim. But if, say, the original creator of our target program updated it in some way, added a function or removed a function or did, you know, one byte could screw it all up. Modified a function that was above it, you know, it would cause this address to change. So normally what you would do is actually copy the hex that is unique to this function and search for it. Or you could actually create a function signature that's like much like this. It's how many variables, how many arguments, what's the return type, approximately how many bytes is it, what's it do to the stack. You can make a signature like that, but it's much easier to just grab from the very top of it. You know, we could even click here and it's going to be the same place. So you grab from the very top of it down to the very bottom of it, which is here. But things like addresses and this call, those are going to be different. So really you're only going to need like maybe from here to here, but of course this offset could be different also. Well, that's okay, because in the function that we would write to actually search for it, we could use question marks or something to make wildcards. It says, well, we want all of these to match, but these certain ones, these certain bytes, they don't have to match. And if we find it, then we just return the first byte that we found it, the sequence at, which would be the top of our function. we'll get more into that in the 5th video, or maybe that will be an extra video. I'm not sure yet, because it's not, I mean, it is important because you want your automation programs obviously to be dynamic. Like if you're writing a bot for a game or something, you want that game, you know, when it patches or updates, you want your bot program to just work. You don't want to have to update it every time they release a patch and their offsets change. You know, they could recompile it and it could get a different base address. If they used virtually allocated memory to store a static library or something, those offsets could be different every time it loads. And so a way around that is to generate these dynamically searching functions, log them all, and then call them from what you found. There is a possibility of false positives, but you just work around it, or you could even find the locations by reference. You find somewhere in the code that's unique that calls it, and you look for that, and then you grab the bytes from the call. So enough on that. For now, we're just going to use 401348. So if we come back in here, we would define output string equals, and it's going to be a void pointer char pointer, I believe is how that's done. Let's see, it's going to yell at us. And then we would do OX00 401348 401348. And now, what's it saying? This declaration has no storage class or type specifier. That would be because, well, I'm not entirely sure. Let's take that out and see what it says. It's going to say the same thing. Why is it not recognizing this as a function pointer? Void output string char pointer output string equals. We don't need the star. We don't. Give me 1 second. Alright, so I pulled up function pointers here, and we see that we were right on here with void foo. So my function, and then they're assigning foo. So why is ours not working? Is it because we're trying to do it globally? Let's try to toss it in here and see what it does. Alright. Okay, so I guess we aren't going to do them globally. We're going to do them at the top of our window procedure? No, let's do it in the main. That would be probably better, but I don't think we'll have access. Yeah, we will, I think. Only one way to find out. And now it's just complaining because it wants it to be a void pointer char pointer cast. There we go. And then, are we gonna be able to actually call it in here? So if we do this, it's undefined. That's what I thought. And if we define this globally, it's probably gonna yell at us. Nope, it doesn't. Okay, cool. So we can put it here, and it's not yelling at us here either. So I think that will work. We'll do declarations up here, prototypes up here. they're kind of like type defs. There's another way you can do function pointers that I've always done with type defs, but this actually looks cleaner than that because it involves a whole lot more casting. So let's go ahead and build this, see if it will build for one, and then see if it still outputs this. See if it even builds. I'm going to pause it so it's not too necessarily... Oh, looks like it's going to go now anyways. Okay, here we go. So let's minimize this guy and go to debug, grab our new compiled DLL, toss it in binaries, overwrite it, run dummy, run our program, and we see that it does still print it. And we're not using printf, we're using the functions function. Alright, so let's pull that back up. We know that that's working, but we want to pass it a string. We don't want to just have a predefined string in our DLL. Now if this was like something super simple, we could say we sent %d-n, and this obviously isn't going to work because it only takes a string. It's not a printf. The format is just %s. So we can't do that. We have to do the string formatting ourselves beforehand and then actually send it. So we want to actually send a char pointer of lparam, but where are we gonna, from our program, how are we gonna access the memory of a character pointer from our program? There's a couple ways we can do this. One way that we could do it is within our DLL's initialization, we could make a buffer and actually have it send back to our program the address of that buffer, and then we could write to it from our program, which is what we're gonna do in the end, but for now we're gonna use virtual alloc. So in our program we're just gonna virtually allocate some memory because we already do that once here. And we obviously still have access to our process, so why not do it that way and then pass it? So let's go ahead and build this and copy it over to our binaries, replace it, and then in our program let's do this again, but up here, and not DL virtual location. We want just string buffer, we'll call it, virtual alloc ex h process 0. No. What are these arguments? Well, let's look them up really quick. And Shazam, here we are. We see process, an optional input for a LP address. So that is the pointer that specifies a desired starting address for the region. So we don't care. Wherever it makes it, it makes it. The size we do care about, and the type and the protection we do care about. So we pull this back up and we want string length of, well, let's make a new string, and that's very easy to do. You should never copy and paste code because that's how you make errors, but we're just gonna do it. Out string, and we want to say this is my string that I sent, and we'll just out string here, dword X1000 and dword X4. Well, what does that mean? Well, if we want to know, we can come down to X1000 is memory commit, which we could just type in mem commit. Let's go ahead and do that because it makes more sense in English. That's why we have high-level programming languages, because people didn't want to remember every opcode. And yeah, so then the protection, so here's the type. You come down and we see the protection, and it just says, hey, look here. And we're like, okay. So we are currently using X4, which is execute, read, write. Makes sense. We want to be able to execute it, we want to be able to read it, we want to be able to write it, sure. So we can still just write that. Now we need to pass in the L param the address of that, and that's very easy. It's going to be returned to string buffer, the address that it writes this, or it allocates for us. Well, we haven't written anything to it yet. Haha, let's write process memory and actually put our string there. String buffer, wait, that's not right. This is string buffer. Again, never copy and paste code. Normally you wouldn't because you'd be writing it, but I don't want to type it. So there we go. We want to write to this process at this address that we just got. Our out string, how many bytes? Well, the length of it. Alright, so now we can post our message to the DLL window with our message code 0 for a W param, which we could use to pass another argument, which we're going to get into that a little bit more in the next video. And then we pass the address to our string buffer. Alright, cool. Well, let's execute, compile. It's yelling at us. Invalid conversion from LP void to L param. Ah, well, that's easy. L param. Good to go. Execute, compile, and it's good. I don't care. It's a warning. Don't care. So inject my DLL object or output and blank. Yeah, I did rename it to our program before. It compiles as blank. Shouldn't have done that, but oh well. Don't get confused. Just don't. Go to binaries, Control V, we got blank in here. Cool. So if we run dummy, and then we run blank, this is my string that I sent. So we allocated some memory within the program space, wrote our string to it, and then our DLL was able to access it as if it was just any other variable. Pretty simple, pretty easy. And since this video is already a half an hour long, I'm not actually going to go into another function. But currently we see that we can now pass it any string that we want. Now, I wouldn't want to replicate this code 18 million times, so I'd write a function that actually takes a string, allocates the memory, writes it, and then posts a message, and then it would process the return. We're going to get into that in the next video because we need to set up our program with a space in memory that we can continually use to process return values, and we're going to do much the same in our DLL so that we don't have to continually virtually allocate memory. We're just going to, on injection, talk back to our program and say, hey, this is the address to the buffer that I want you to write things to, and then we will. And our W param is going to be most likely length of bytes, and then in our case statement we'll be able to tell, or just a name, like we could pass an int that corresponds with the argument type that we're sending it. Well, most likely we're going to be sending a structure because we're going to have more than one argument. But yes, that's going to be the next video, and I'm actually going to write it ahead of time and prep for it so that we don't have to spend a half an hour writing like 4 lines of code like we just did. But I hope that you enjoyed this and you learned a little something, and I hope that it kind of paints a picture of where we're going with the next video, and I'm gonna try to do that tomorrow morning. If not, it won't be until probably Thursday when I get that out. And then if we feel like we've done enough on this topic, we will move into actually learning how to do things that are a little more fun and kind of basic building blocks to be able to open any program and figure out what it's doing, what structures, what arguments are being passed, what parameters are being passed, what type of return is it. The things that you need to know to actually be able to tear apart a program, figure out what it's doing, and make it do what you want it to do.